This lesson will focus on simultaneous equations, type 1 from National 5. If a family of 2 adults and 3 children go to a theme park with the cost of admission being £36, there are a variety of possibilities for the cost of an adult and child which make £36. One option could be £15 per adult and £2 per child, totalling £36. Another option could be £18 per adult and children go free, totalling £36. How do we know what the cost of an adult and child is? If given 2 options for the same scenario, we can solve the problem. So for example, 2 adults and 3 children cost £36, whilst 1 adult and 4 children cost £28. Rather than solving through inspection, we can make equations and solve these simultaneously to calculate our unknown values. We solve the values through a process known as elimination. To solve for 2 unknown variables, we require 2 equations. This is always our starting point. Example 1. Solve the following pair of equations. 3x add y equals 7 and 2x subtract y equals 3.
When asked to solve for 2 unknown variables, now remember a variable is simply just a letter, we must always start by checking that we have 2 equations. Once we have our 2 equations, we'll always write these above and below one another, and we are always checking for 2 things. We want to have the same coefficient on one of the letters, yet different signs. So for example, if we look here, you'll notice that in front of the x, the coefficient of the x is different, so we don't really want to deal with that. However, if we look at the coefficient of the y, that is both 1. We then want to check that we've got different signs, so we have one positive and one negative. When this is the case, we are going to add our 2 equations together. So, underneath our equations, let's just draw a line just to keep them separate. At that stage, we are going to add them together. So if we add, let's just put this at the side here. We're going to add them together. 3x adding 2x gives me 5x. Positive y add negative y, well that eliminates, so let's score through that because it eliminates. We'll leave our equal symbol here, and then we have 7 add 3 is 10. This has now allowed us to just have 1 unknown variables that we can solve for. 5x is equal to 10. That therefore means that x is equal to 2. After we've solved for 1 unknown variable, we'll now solve for the other one. So we have solved for x, now we're going to need to solve for y. To do this, you always want to substitute it into the first equation. So therefore, 3x add y equals 7. When x equals 2, we will now have 3 multiplied by 2, add y is equal to 7. This will give me 6, add y is equal to 7, so y will be equal to 7 subtract 6, which means y is equal to 1. Therefore, x is 2 and y is 1.
Example 2. Solve the following pair of equations. 5e subtract f equals 13. 3e add f equals 11.
In example 2, you'll see that we have 2 equations with 2 unknown variables. To allow us to solve them, we must always be checking for one of the terms having the same coefficient, yet different signs. So once again, if we look here, E, we don't have the same coefficient. F, we have a coefficient of 1. Remember, coefficient is simply just the number in front of the letter. We have a coefficient of 1 and we have different signs. Now that we have both of those, let's just draw our line underneath to separate our working. Whenever we have the same coefficient yet different signs, we add our equations together. So we will add these together. Okay, 5e add 3e gives me 8e. Negative f add positive f, that eliminates. We will leave our equal sign here. 13 adding on the 11 will give me 24. You can see we've eliminated term f, so now it allows us to solve for e. E will therefore be equal to 24 divided by 8. So e is equal to 3. I've solved for e, now I want to solve for f. Therefore, always put it into your top equation. 5e subtract f is equal to 13. So when e is equal to 3, we are going to have 5 multiplied by 3, subtract f is equal to 13. 5 multiplied by 3 is 15. Subtract f is 13. A couple of different ways to do this. Some people like to leave the letter on the left. Some people like to make the letter positive. It doesn't matter which way you do it. Let's, for example, leave this as negative f is equal to 13. And I'm going to take positive 15 over to become negative 15. I now have negative f is equal to negative 2. When you have a double negative, i.e. a negative on both sides, we can cancel that away. So f is equal to 2. Bring your answer together. Therefore, e equals 3 and f equals 2.